Hey there, welcome. So you've heard the words KVM, QEMU, Hypervisor, and your brain went, wait, what? Don't worry, we're starting from scratch, and I mean scratch. Before we even touch KVM, we need to understand what a Linux kernel actually is. So let's go.
All right, think about your computer. At the bottom, you have physical hardware, your CPU, RAM, storage, network card. At the very top, you have your applications, Chrome, VS Code, games. But here's the thing. Those apps can't just talk to hardware directly. They'd break everything. So who sits in the middle? The operating system, specifically the kernel. So the kernel, it's basically the boss of your entire computer. It manages 4 key things: memory, the CPU, your devices, and system calls. When Chrome wants to open a file, it asks the kernel. When your music app wants to use the speaker, kernel. The kernel is the gatekeeper between software and hardware. Think of it like a really strict hotel receptionist. Everything goes through them.
Here's an important concept: kernel space versus user space. The kernel runs in its own protected memory zone called kernel space. Your apps run in a separate zone called user space. Apps communicate with the kernel through something called system calls, like a polite request form. This separation is super important for security and stability. If one app crashes, it shouldn't take down your whole system.
Quick sidebar, there are different types of kernels. Linux uses what's called a monolithic kernel. Everything is packed into one big, powerful unit running in kernel space. Then there's a microkernel design, where only the basics stay in the kernel and everything else is pushed out to user space. Linux chose monolithic because it's faster, less switching between modes. Cool, right? Okay, now let's shift gears to virtualization. Imagine you have one powerful server, one physical machine, but you want to run multiple operating systems on it at the same time. Maybe a Linux server, a Windows server, and a test environment, all on the same hardware. That's exactly what virtualization lets you do. One physical machine, multiple virtual machines. Mind blown. So if we're running multiple virtual machines, who manages all of them? That's the hypervisor. Think of the hypervisor as the ultimate manager. It sits between the hardware and all the virtual machines. It allocates CPU, memory, and storage to each VM. There are 2 types. Type 1 hypervisors run directly on hardware, like in data centers. Type 2 hypervisors run on top of an existing OS, like on your laptop. Let's dig into Type 1 and Type 2. Type 1, called bare metal, runs directly on physical hardware. No host OS in between. Examples: VMware ESXi, Microsoft Hyper-V, and, you guessed it, KVM. Type 2 runs on top of a normal operating system. Examples: VirtualBox, VMware Workstation. Type 1 is faster and more efficient. Type 2 is easier to use on personal machines. Now the star of our show, KVM. KVM stands for Kernel-Based Virtual Machine. It's a virtualization technology built right into the Linux kernel, not separate software. It's literally part of the kernel itself. Since Linux 2.6.20 in 2007, KVM has been included by default. You don't need to install extra software. If you're running Linux, KVM is probably already there. Let's look at how KVM actually works. KVM turns the Linux kernel itself into a Type 1 hypervisor. Here's the magic. KVM adds 2 kernel modules, kvm.ko and kvm-intel.ko or kvm-amd.ko, depending on your processor. These modules expose a special file called dev/kvm. Any program can use this file to create and manage virtual machines. The kernel then handles memory, CPU scheduling, and hardware access for those VMs. Here's where QEMU comes in, and this is where people get confused. QEMU stands for Quick Emulator. By itself, QEMU is a software emulator. It can pretend to be a full computer, CPU, RAM, network card, storage.
all in software. That's slow. But when QEMU teams up with KVM, it uses the real hardware instead of emulating it. This combination, QEMU plus KVM, is how you get fast virtual machines on Linux. Let me make this even clearer. QEMU without KVM, every single CPU instruction the guest VM runs has to be translated and emulated in software. Super slow. QEMU with KVM, the guest VM runs CPU instructions directly on the real CPU. The hardware handles it natively. We're talking 10 to 20 times faster performance. This is why cloud providers like AWS and Google Cloud use KVM under the hood for their virtual machines. For KVM to work, your CPU needs to support hardware virtualization. Intel calls this VTX. AMD calls it AMDV. These are special instruction sets in your processor that let KVM run guest code directly on the hardware safely. You can check if your CPU supports this by running the command egrep-c in single quotes vmx or svm in quotes /proc/CPU info. If you get a number greater than 0, you're good to go. Let's get practical. Installing KVM on Ubuntu is surprisingly easy. You run sudo apt install QEMU-KVM libvirt-daemon-system libvirt-clients bridge-utils virt-manager. That's it. This installs KVM, QEMU, libvirt, which manages your VMs, and virt manager, a nice graphical interface. After install, add yourself to the libvirt group so you can manage VMs without sudo every time. You'll see libvirt mentioned a lot with KVM. What is it? Libvirt is a management API and daemon that sits on top of KVM. It gives you a consistent way to create, start, stop, and manage virtual machines, whether through command line tools like virsh or graphical tools like virt-manager. libvirt talks to KVM through dev/KVM and handles all the complex setup for you. It's the friendly layer on top of the raw power of KVM. Here's a question beginners always ask. What's the difference between a virtual machine and a container like Docker? Great question. A VM virtualizes the entire hardware. It has its own OS kernel, memory, everything. Heavy, but very isolated. A container shares the host's kernel, much lighter and faster to start. Think of VMs as full houses and containers as apartments in the same building, sharing the walls but separate living space. Let's trace what happens when you create a VM with KVM. Step 1. You use QEMU or virt-manager to define a VM configuration. How much RAM, how many CPUs, what disk image. Step 2. QEMU opens /dev/KVM to request kernel assistance. Step 3. KVM reserves memory, sets up CPU contexts. Step 4. The guest OS boots and runs its instructions directly on the hardware CPU. Step 5. You have a fully running virtual machine. All of this happens in milliseconds. Let's talk about memory virtualization. How does each VM get its own memory without conflicting with others? KVM uses a technique called extended page tables, or EPT, on Intel, and nested page tables, or NPT, on AMD. Basically, there are two layers of memory translation. The guest OS thinks it has its own physical memory, but KVM transparently maps that to the actual physical RAM. The CPU hardware does this translation super efficiently. Every VM needs storage. In KVM, virtual disks are stored as files on your real disk. The most common format is QCOW2, QEMU Copy on Write version 2. It's smart. The disk image only uses as much space as the VM actually needs. You can also take snapshots with QCOW2. Other formats include RAW, which is simple and fast, and VMDK from VMware. You create disk images using the QEMU IMG tool. How do VMs talk to the network? KVM offers several networking modes. NAT mode. The VM gets internet access through the host, like your laptop sharing its Wi-Fi. Bridge mode. The VM gets its own IP on your network, like a real computer plugged in. Host-only mode. VMs can talk to the host, but not the internet. For most dev work, NAT is the easiest to start with. Power users use bridged networking for full network presence.
Let's talk virsh, the command line interface for KVM. Some essential commands: virsh list -all shows all your VMs. Virsh start my VM starts a VM. Virsh shutdown my VM cleanly shuts it down. Virsh snapshot -create -as my VM snap1 takes a snapshot. Virsh dom info my VM shows VM details. If you love terminals, virsh gives you full power to manage all your VMs without touching a GUI. It's like having a control panel in your terminal.
Not a fan of command lines? No problem. Virt Manager is a graphical desktop app for managing KVM virtual machines. You can create new VMs with a wizard, see live CPU and memory usage, manage snapshots, configure networking, all with point and click. It's especially great for beginners. Virt Manager connects to libvirt, which then talks to KVM. Same power, friendlier face. Here's something mind-blowing. When you rent a virtual machine on AWS, Google Cloud, or even many other cloud providers, there's a good chance KVM is running underneath. AWS uses a custom hypervisor called Nitro, which is built on top of KVM. Google Cloud uses KVM directly. Azure uses a mix. KVM powers millions and millions of cloud VMs around the world. The thing you've been learning about? It's running the internet. How does KVM stack up against other hypervisors? VMware is the enterprise gold standard, super feature-rich but expensive licensing. Microsoft Hyper-V is built into Windows Server, good if you're Windows first. KVM is completely free and open source, built into Linux and used by the biggest cloud companies in the world. For Linux environments and cloud workloads, KVM is the go-to choice, and it costs you nothing. All right, amazing work getting through this. Let's do a quick recap. The Linux kernel is the boss of your system, managing hardware access. A hypervisor lets you run multiple virtual machines on one machine. KVM is a Type 1 hypervisor built directly into the Linux kernel. QEMU is the emulator that teams up with KVM for fast VMs. libvirt and VIRS help you manage them. Now, your next steps? Try installing KVM, spin up your first VM, and explore. You've got this.